Physics NCERT, Class 11th, 4th chapter, which is Motion in a Plane, question number 4.30. So, in this, a fighter plane flying horizontally at a distance at a height of 1.5 kilometer and with a speed of 720 kilometer per hour passes a directly overhead anti-aircraft gun. At what angle from the vertical should the gun be fired with muzzle speed of this in order to hit the plane? So when we draw its schematic, it will be like this. At the ground, a gun is there, and directly above this, at a height of 1.5 kilometer, at a height of 1500 meter, an aircraft as fighter plane is flying. A fighter plane is flying at a height of 15 meter from gun with a speed of 722 km per hour, which is equal to 200 meter per second. So in this we have to find the angle made by the gun with vertical in order to hit the fighter plane. So fighter plane is moving horizontally. After t time, the bullet would reach. After t time, the bullet will reach the fighter plane. So in order to hit the fighter plane, both must have same displacement in x direction. So let's say the displacement of fighter plane in x direction is x. So displacement of bullet in x direction should also be x. So use different equation for bullet and fighter plane. So first we are taking case of bullet. So for bullet, displacement in x direction is equal to ux into t. Displacement of bullet in the x direction is equal to x, and let's say this speed is 600 meter per second, and a component of this velocity along x is equal to 600 sine theta into time t. For plane we can say sx is equal to ux into t. Plane also have displacement x, velocity of plane in x direction is 200, and time would be same for both bullet and plane. Equating both the equation, this is equation 1 and this is equation 2, we have 200 into t is equal to 600 sine theta into t. From with this we can say that sine theta is equal to 1 by 3. And when sine theta is equal to 1 by 3, this implies that theta is equal to 19.5 degree. So we have 19.5 degree, which is our first part. So at what angle from vertical should the gun be fired? So theta is equal to 19.5 degree from vertical. Now for second part, at what minimum height should the pilot fly the fighter plane to avoid being hit? So if the height at which the fighter plane is flying remains greater than h maximum, then it could be safer for him. Second part, so in order to be being avoided by hitting the gun, so height of plane should be greater than h maximum of bullet. So let's find out h maximum of bullet. So maximum height of bullet is given by uy square upon 2 into g, where uy is velocity of bullet in y direction, which is equal to u square cos square theta upon 2g. So from this, h maximum of bullet comes out to be u square, that is 600 whole square into cos square 19.5 upon 2 into z. Let's take the value of z equal to 10. So h maximum is almost equal to 16 kilometer. So to be on safer side, height of plane should be greater than 16 kilometer from ground.